Hi everyone, it's Paul from This Design That. Today I'm going to be going over the CNC electrical enclosure that I have just finished rebuilding. Now this has been a very long project. One of the biggest reasons for that is that this is my first time doing this, and I don't have that much experience with electrical wiring and setting up these type of systems. It was a lot of reading and watching that I did on YouTube to get to this point. I think I decommissioned the CNC much early in the year. This has probably been over 6 months worth of work. But yesterday I finished pretty much most of the things with the enclosure, and I was able to get the machine moving on all axes with just a little simple program that I wrote. If your CNC has been out of operation for 6 months like mine, or if you don't even have a CNC, fear not, because you can still have your parts fabricated by using the sponsor of this video, PCBWay. They offer a huge range of fabrication possibilities. You have up to 5-axis CNC machining, there's turning, and there are a range of materials to choose from. You have common materials like aluminium, brass, and stainless steel. There's also engineering plastics like PEEK, and all parts can be tapped, threaded, assembled, and you can even go as far as having a CMM inspection with a report. So as you can see, PCBWay have you covered. So head over to their website, PCBWay.com, and have a look for yourself. So this is probably going to be a multi-part series. I'm probably going to go over a lot of things here, but then I'll also go over a few extra things in a little bit more detail in other videos. So let's start first of all of why am I upgrading the electronics of my CNC? Probably the number one reason was reliability. So this is a Omeo, I think it's an X4 CNC. It's essentially a Chinese 30x40 CNC. The electrical enclosure, they all use pretty much the same components from what I can see. There was a few reliability issues that I always come across with this CNC controller. So first of all, it is using Mach 3 with this controller. Pretty sure it's a cracked version of Mach 3 because there's no way to update it. You don't get a license with it or anything like that. So you are just stuck with a very old version of Mach 3. Also, I had a bug where whenever I would click on the go to 0 button, it would always go -5mm, and it would crash into workpieces so many times, and I destroyed so many end mills by forgetting about that bug and just clicking on go to 0. Another issue that I always had was running various different scripts or doing any sort of probing would always throw up some sort of error message. And then the last reliability issue that I always had was that whenever my compressor would turn on and off to cycle to fill up the tank, it would always throw an E-Stop error. I was not using the same power switch, but they were running in the same room, so it could have been on the same circuit. I did find that if I connected the compressor with an extension lead to another socket in my house, in like another room, I wouldn't have that issue of the E-Stop and cutting out the operation. It was very unreliable. And this isn't too much of an issue when you're doing very simple jobs, which is just one end mill, one operation, that's fine. But once you start coming into multi-operation jobs where you've got to maybe flip over things, you've got to do changing of end mills, setting different heights and offsets, it just becomes really, really annoying to the point where I just kind of made sure that the things that I was doing was pretty much as simple as possible. I didn't really like that because I really did want to experiment and learn more about CAD and CAM. Another reason I chose to upgrade was that there was no expandability options with the old setup. If I want to run coolant and have it controlled by valves and all those type of things, yeah, you basically can't do it with the controller and the setup that you've got with these Chinese CNC machines. And then lastly was the safety aspect of it. When I opened up the CNC controller to salvage some of the parts, I noticed that pretty much nothing was grounded. The EMI filter was grounded, but then from that, nothing else was grounded. The controller, the VFD, the power supply for the stepper drivers, none of that was grounded, which yeah, it's just like basic electrical safety. I wanted to do it myself, learn how it's all put together, and hopefully do it as safely as possible. There are a lot of different controller and controller software options available. If you have a search on Reddit, you'll see that there are a few that get mentioned quite a lot. Mach 3, Mach 4, and I did want to move away from Mach just because I've already used it and I didn't really like it because it was a cracked version. I'm pretty sure that Mach 4 is probably okay. There's also UC-CNC, there's Linux CNC, and I think Centroid or Acorn or something like that. I went with UC-CNC, and the reason why I went with it is that the company that developed the software, they develop the controller, the AXBBE, and the E stands for Ethernet connection. So I really did like the fact that it was all one closed ecosystem and they pretty much had control over all of the parts, hardware and software. Yeah, I'm just hoping that that's just going to make it a more user-friendly experience, and when it comes to bugs and those type of things, it's going to be able to be fixed more quickly. That was the first thing I purchased. I got an AXBBE controller, and after about an hour of playing with it and just making sure that it powered up, I put it away and got on with other projects, and I come back a few weeks later, wired it up again, was not thinking, and I plugged the 24-volt power into the 5-volt power, and I fried the controller board. So one tip I would say is, try and do it all in one go. Have it set up, have it wired, and just work on it. I was coming at this, working on multiple different projects. Yeah, I just wasn't thinking, and I mean, this is like about 220, 230 pound, and it just fried it. There is a way that you can possibly use it by overriding the voltage protection, and you can probably do some SMD soldering and maybe fix some of these components, but I unfortunately just bought another one and I wired it up, and I did not disconnect it after that. It pretty much stayed connected to that 5-volt, stayed connected to that 5-volt power supply for the rest of this project. So next, once I got the controller, it was time to start thinking about the rest of the components and how exactly I was going to build this enclosure. So what I want to do is I just want to go over some of the guiding principles that led me to the way that I built my enclosure, and hopefully it will help you if you're a beginner and you're new to this. The first thing was moving away from a USB connection to the controller and going with an Ethernet connection. USB is just more susceptible to interference, so going with an Ethernet connection is just going to be a little bit more robust, and it also means that you can have a greater distance between the computer and the controller. I'm not sure why that's so preferable, to be honest with you, because usually you're going to have it in like the same room. Unless you've got a huge room, it's probably not that important, but yeah, it's a nice thing. You can at least run an Ethernet cable to the other side of the room and not have too many issues. Unlike the Chinese electrical enclosure, I'm actually going to use grounding with this one, and I'm going to use star point grounding, and that is essentially a common ground bus will be implemented in the enclosure, and all of the individual components, all of their ground, will go to this star ground point, and then from the star ground point it will go to obviously the mains connection. And again, this will just help reduce ground loops and interference, which interference is the thing that you want to try and minimize as much as possible with these enclosures, because obviously you are sending data, you're sending signals to drivers and to motors. You don't want that data to get corrupted and obviously result in incorrect movements and things like that. The next principle is separating your high power and low power wires. Now this is obviously dependent on the size of your enclosure. A lot of builds that I've seen, they've tried to cram as much in to a small enclosure. I've gone with quite a big one. It is 600 by 600. I personally kind of wish that I went with a smaller one now. There is a huge amount of space left over in here, but I guess once I do add maybe more accesses and solenoid valves and all of those type of things, it is going to fill up a little bit more. And I guess it is very nice to have a lot of space to work in. I do think this could be a little bit smaller because it is quite heavy and it's just about going to fit underneath my my CNC enclosure. If possible, separate the high power and low power. So you can see with this enclosure on the right side here, I've got the mains coming in. It's going through a Latching E-Stop. It's going into these distribution blocks. It's feeding the power supplies. It's feeding the VFD. And then on the left side, I've got the lower power, which is the controller, the drivers, and obviously they're feeding out into the motors. I was trying to figure out how much distance you actually need for the EMI to not affect cables next to it. Just from what I could see, a few inches is enough to minimize the interference that cables can feed to one another. Yeah, hopefully this is definitely going to help. I've got a good few inches in between the high power and low power sections here. The next principle is to use shielded cables, and preferably double shielded cables for all of your signal connections. Now, pretty much all of the signal connections in the controller are from the controller to the stepper drivers, and then obviously feeding out of the enclosure, the cables going to the actual stepper motors themselves. They should also be shielded, and also your spindle connection from the enclosure to the spindle, that should also be a shielded cable. Double shielded is quite a bit more expensive than the single shielded that I can find, but I did find a decent supply on AliExpress. And I think I was able to get, I think 10 meters of 5-core double shielded. It cost me, I think, around about 25 or 30 pounds for it to be delivered for 10 meters, which was enough to do all of my stepper motors. It's not too bad, but I mean, you can certainly get cables much cheaper if you look for single shielded, but bare minimum, it needs to have some sort of shielding. And the next principle is that all of the shielded cable needs to be terminated to the common ground bus. So the actual metal wire shielding that you get in this shielded cable, you need to solder a connection to that and terminate it to the common ground bus. So then the interference or the radiation has somewhere to go to, basically. If you don't ground your shielded cable, it's pretty much not doing it. And also there is a lot of debate on, should you ground both ends of the shielded cable. From what I saw, most people say that no, you don't need to in most instances. So I have only grounded the one end of the shielded cable. The next principle is that you should have some sort of latching E-stop mechanism in the enclosure. So the reason for a latching E-stop is that you have a contactor which will turn on and off the higher powered components in your enclosure, that being the power supply for your stepper drivers and also the VFD. If there is a loss of power or if you hit the E-stop, that latch will turn off, and the only way to bring it back on is through a manual operation of you pressing the power switch back on to turn on that latch. So this is important if you do have a power loss and then the power comes back on. You don't want the stepper driver and the VFD powering back on and potentially making the machine run when you don't want it to. And also it's just a little extra safety check because, as I said, it does require you to press the button and turn it on again. So it just makes you that little bit more aware of, is the machine in the right position? Is the work holding okay? Is nothing gonna kind of explode or kind of rip apart if I turn this back on? The other principle is to use GX connections. These are the aviator sockets, and you can get all different configurations in terms of size and the amount of pins. And what I've done is I've gone for an extra pin for the stepper drivers to the stepper motors, and that is so that I can then continue the ground on that extra 5th pin onto the shielded cable that is going outside of the enclosure. So generally for stepper drivers to the motors, you would have 4 pins, but there is no way to carry that grounded shield connection into that cable that's going outside of the machine. So yeah, I've gone for 5-pin GX connections for all of my stepper drivers. A few little extra things I've done just to try and make my life a bit easier is I'm using DIN rails for the mounting of all my components, and all of my power supplies, things like that, they are all DIN rail mountable. And then using the DIN rails, I've got DIN rail distribution blocks to distribute all of the power, which are really nice and easy to use. I've got the push connection ones, so you just literally use a screwdriver to push down a connection. You can just push in your ferrule and let go and it will stay connected. It's a really nice, quick and easy way to get things in and out. So those are the core principles that I picked up from doing hundreds and hundreds of hours of research into how to build an enclosure. I think those are probably the most important things that you need to consider when you are starting to build an enclosure. What I'm going to do now is I will show you the wiring diagram to show you how exactly I put all this together. So this is the basic wiring diagram. First of all, I have a mains power switch. So that is just a kettle lead that I plug into the enclosure. So straight away, the live, neutral and the ground, they go into an EMI filter. And this is just the EMI filter that I had left over from the old enclosure. The ground will then split off of that filter and go to the ground bus bar. The live and the neutral will then go through a main switch. So this is, I've essentially got a switch on the mains power, on and off, and then I've got a mains switch also at the front of the control panel as well. So this is kind of like the main on and off switch. So from there, when I turn on the switch, the live and the neutral, the live will go through an MCB, and this is, I believe it's a 10 amp breaker, and that's pretty much what all of these components, I think that's really the maximum of what they're going to be using. It then goes into, from the MCB, it then goes into the 230 volt live bus and a 230 volt neutral bus, and also it goes off the live and the neutral, the mains, will go into a normally open contactor. So this is essentially a relay, and the coil in this, which is the switch to turn this contactor on and off, is powered with 24 volt DC. So that is actually fed from the 24 volt power supply, which I'll show you down here. We've got the live and the neutral. It's going into the mains live and the mains neutral bus, and these are the little terminal blocks that you can see here. So you can just clip them into your DIN rail, and you just push these little orange buttons down with a screwdriver, and you can just slot in your ferrules. So it's really nice and easy to install the wiring for this. From there, the live and the neutral, it will feed into my two power supplies. So I've got a 24 volt, I've also got a 5 volt. The reason I've got that is obviously, first of all, 24 volt will be powering the fans. It will also be powering, as I said, that normally open contactor coil. And also the AXBBE, it does require both 5 volt input and also 24 volt input. As soon as I turn on the main switch, the power goes into the bus. It is then fed into the power supplies, which will then go into their own 24 volt buses. And again, I'm just using these terminal blocks here. And then from there, the 24 volt will feed, and also the 5 volt will feed into the AXBB, and it will turn it on. At the moment, that is all that is turned on. When I turn on this main switch, all that happens is my power supplies are powered up, my AXBB turns on so I can connect to it, and obviously the 24 volt buses and the fans that are connected will all turn on. I've got a latch-in start-stop. This is not obviously the correct wiring for this. I will show you a more detailed wiring diagram for a latch-in start-stop and some resources to help you figure it out. But essentially it goes through a normally open contact, a normally closed contact, and then also I've just run it through a emergency stop as well. So when I press the green button, it will turn on this latch, and it will turn on the contactor, which will then allow that mains, that 230 volt mains, to flow into the higher powered elements of the enclosure. That is the 48, I think it's 40 or 48 power supply. Again, I just reclaimed this from the old electrical enclosure, and also the VFD. So when I press that green latch start stop, you hear the VFD and you hear the stepper drivers and the 48 power supply turn on. From there, it obviously, the 48 volt, it will power up the 3 stepper drives. Now the power supply that I've got, it does actually have, on the power supply itself, it's actually got 3 positive and negative outputs. So I didn't actually need to run this power supply into a terminal block distribution before running it into the stepper drivers. If I do want to add another stepper drive, which I probably will in the future, then I probably will have to have a similar setup with this, where I'm feeding the power into a terminal block distribution, and then I'm feeding it out into the drives. From the drives, I've got a 5-pin connector for the drives. 4 is obviously for the motor control signals, and that extra 5th pin is that ground, so then that ground can carry on externally out of the enclosure to the motors. So you can see that all of the grounding, so I've missed out a ground here as well. Let me just put this in. So all of the grounds from the stepper drives, from all of the connectors, the VFD, the 48 power supply, the 48 volt power supply, the 24, the 5 volt, all of those grounds will all go into the ground bus bar, which is obviously connected to the filter and through to the mains. And then lastly, the signal connections from the AXBB going to the stepper drives and also to the VFD, they are shielded cables. So this is the basic setup, and in retrospect, it looks so simple now that I'm looking at it. But honestly, this took me 100+ hours in kind of researching and just trying to understand how all of this stuff works. There are a lot of good resources and videos out there, especially for things like wiring up the latch-in start-stop. And again, I'll provide some resources for that. Only thing you need to make sure is obviously that your fans, make sure that you've got the right power supply for the fans that you get. So you want to make sure that, if you've maybe got a mains one, 5 volt, 24 volt, whatever your power supply is, I'd probably go with a fan like that. Generally, you want to place an inlet and an outlet fan. Ideally, you would have the inlet fan at the bottom of your enclosure, and then it will create a cyclical effect because obviously the fresh air will be drawn in, the hot air will rise, and then it will be exhausted out from the top. So you want to try and get some sort of circular airflow through your enclosure. Me, as I'm actually going to be laying my enclosure flat underneath my CNC enclosure, I don't really have that effect of the hot air rising. So I'm just going to be putting just a fan on either side basically, so I've just got some airflow going through this enclosure. So that's the first part of this series finished. I guess the next steps will be to move all of this back downstairs into my enclosure and to probably start doing some test cuts. A few little extra things I need to do with the enclosure, which I will show in another video, and that is to finish drilling some holes for some fans and some more buttons and some more connectors for when I do eventually upgrade to another access and add in maybe some coolant relay. So I want to get those drilled in now before I move it downstairs. But if there's anything that you specifically want to know with this enclosure build project, let me know in the comments below and I can add it to the list of things to talk about in this series. So thank you for watching, and I will catch you all later.